So as we start looking at chapter 4 is basically going through and designing our studies. How are we going to go about designing an observational study or an experiment? How can we do it to try to get as truthful data as possible so that we can make some inferences later on? So as we refer to things later, is when we get into chapters 8, 9, and 10 and beyond, when we talk about doing a simple random sample or someone came from a simple random sample, it's based off of this chapter right here. All the techniques that we talk about, how can we gather our data in a unbiased way, that way we can make some proper inferences about a greater population. So that's what we'll focus through as we go through today and tomorrow with it. So again, we see studies all the time on the news and in old days when it was newspapers. We used to see different studies that are published. Usually we see them come up on the news or I hear them on the radio from time to time. We have two different types of things. We have an observational study and we have an experiment. Observational studies observe individuals, measure variables of interest, but do not attempt to influence the response. Measuring occurs from watching or surveying. An experiment deliberately imposes some treatment on individuals to measure their response or responses. The goal of many statistical studies is to show that changes in one variable causes changes in another variable. Remember, though, causation is different from association, and that's kind of how we finished up in that last section of chapter 3, 4, in section 3, 3. Now, those definitions, we've had them for several years for different end-of-course exams and algebras for us to be able to pick which one's a census, which one was an observational study, which was an experiment. The first step in any statistical study is to identify what your target population. The population is in a statistical study is the entire group of individuals about which we want information on. Do we want to know information about all high school males or all high school males in the United States or all high school males in the United States that play sports? We need to make sure we're specific about our target population. If we're going to include the entire population in your observational study, you would perform a census. Now, we've talked about census before. It's done every 10 years here in the United States. The challenge is it's costly, it's time consuming. It takes a while to get the information to be able to decipher kind of what's going on and then make decisions about it. And so, a lot of times we don't do the entire population just because it's not feasible. Many times too difficult. Again, therefore we take a smaller sample. And therefore from the samples, if we get a nice random sample that is has similar characteristics of the population that we're looking at, then we can go through after analyzing and trying to infer some information about it. So some of the ways to gather data I have listed here. We have what's known as a voluntary response sample. A voluntary response sample consists of people who choose themselves by responding to a general appeal. Sometimes we see that is in a write-in poll or a call-in poll if people are watching some of your different news channels, listening on the radio to talk radio, and they have different polls. You all more with social media, we sometimes get internet polls that come across that we join in, and sometimes of course we try to at least train you as parents, like I train my kids, is hey, you get those pop-ups to try to take part in this survey or that survey, so just swipe it, get rid of it, because you never know what kind of extra cookies are enabled to try to steal your data. So, but I know I see people that take, they share their responses on social media that what their poll result was when they did certain things. We used to have a voluntary response. They could also be sending like a mailer in the mail and filling out some little index card. A convenience sample, you're choosing individuals who are convenient to get results from. You're only sampling maybe you're only sampling your friends. I've used this in past courses. Like if I want to do do a survey or do a study about people who like to read in high school, then if I stand outside the library, I'm going to get people to respond. I'm guaranteed to get people to respond to my survey. The challenge is, if you're coming out of the library, typically it's just a couple things, the reasons why. Either one, you're buying a new ID. Two, you had them print off something for you so you can turn it in for a class. Or three, you're checking out a book. And so there, as I'm asking people if you like to read, probably 80% of the time, people coming out of the library are coming out with a book, or they've just turned in a book. So that kind of alters the results. Systematic sampling consists of a random choosing of a starting value and randomly choosing an interval to ask people at. So this would be something where you say, you know what, I'm going to stand outside the library, and after the fourth person that comes to the door, I'm going to ask them, and then I'll ask every eighth person after that. And so we're trying to start being a little bit more random. However, there is some challenge with it. I know in my college stats class, they actually have a process of actually determining, what the interval of people that you go between for asking. They take, you first have to decide how many samples do you want in a way, and then you take, you kind of take your highest value, lowest value, and divide it by that number. The most common thing we look at is what's called a simple random sample. This consists of n individuals from a population. Remember, n is always going to be known as the number in our sample, lowercase n. And then capital N is always referred to the population. So if you want to put down a little note here, capital N is always to the refers to the population, like the bigger population. And we want to make sure we choose a simple random sample in a way that every person in the population has an equal chance of being drawn. So some of the methods we have the hat method, where you put all names in a hat, choose your sample. Okay? Key thing here is you're choosing that method. You want to make sure that all your pieces of paper are the same size, so forth. And then, you put them into a hat or a bowl, you shake them up, grab one, and then, then you go through and either repeat the process of shake it up and grabbing. You want to talk about some processes. Once you choose a person, you don't put their name back in the hat. You kind of leave them out as you go through, but you want to give everybody an equal chance of being chosen. You have the random number method. Each individual is assigned a random number, and each number must have the same number of digits, and I'm going to explain that here in a little bit. The sample is chosen by using a table of random digits or using a calculator program or computer program. Again, that's what we're going to focus on for a lot of what we're doing here in a moment for the next 10 minutes. Now, what can go wrong? We'll give you a chance to kind of write that stuff down. What can go wrong with sampling? We have what's called sample bias. There's a lot of different types of bias. Sometimes we have wording bias. Sometimes the way things are phrased can lead people to a decision. So when we design a statistical study that shows bias, if systematically favors certain outcomes, like standing outside the library asking if you'd like to read, or standing outside of a fitness center saying, do you like to work out? Or do you feel it's important to work out? It leads to systematic errors which overestimate or underestimate a result. Sampling that leads to bias and systematic errors are samplings that are not truly representative of the population. These methods, sampling methods that kind of tend to have a tendency to have more bias occur in them, are voluntary response samples and convenience samples. And again, some of the other methods could still have it. It's just they're more often occurring in these type of sampling methods for gathering your data. Now, I made a little note here Most studies will require you to describe your sampling methods to ensure you have eliminated any bias. Be prepared to write out how you assign the individual numbers and how you selected your samples. The AP exam usually will give a table of random digits and have you describe your method for a free response problem. Okay, we will see one on our chapter test. So as we go through and we practice this week, you're going to have to go through and explain how you're going to randomly assign what's going on here. And again, we get to talk about here that in a little bit in the process. Correct ways to sample a population. We have our random sampling. Again, using these methods leaves the choice of who participates to chance. So using the hat method, using a table of digits, in some cases using a coin. If you have an option, if you have one of two options of assigning people, let's say a treatment, or are they going to be in the control group, then you could use a coin to determine, as you flip it for each person, you're going into one, you're going into two, you're going into one, you're going into two. And so using a coin sometimes is a way to assign. I guess you could, depending on, it had to be very careful chosen, but if you had a really involved experiment you're doing that maybe had like 6 groups, maybe you can use you could roll a die, a 6-sided die to assign people, have each number assigned to being put into a certain group. So there are also ways to use just physical things to do it as well. A systematic sample is only a random sample if the values are chosen, starting and interval are randomly chosen. There is still some debate out there if it's truly random, because once a starting value is chosen, some people have no chance of being selected. Or it's kind of like, I've used this as an analogy, is how many times at an activity, whether it's church or in school or something, when you figure out how they're numbering people to put them in groups, do you see kids move around to try to get to where there's so many away from a buddy or something so that they can be in the same group and be chosen? Okay, and then so then that it's the other side, is you kind of like rig what's going on there. So there's always that chance. But again, the best option for us to try to do is what we call a simple random sample. And we'll have some examples of different ones coming up here. There's one called a stratified. There's a block and a cluster sample. So we'll talk about some examples of simple random samples and the pros and cons on which one to use. So down here now, what we get to go through is we're going to go through a sample problem, identify the population, identify the sample. What are we trying to measure? And that all comes from the very first part there in the first couple sentences. And then we got to describe, how to determine our sample using a random set of digits here. So as I was talking and you were probably reading, what is the population in that problem in our example here? Remember, population is the biggest. Yeah, 20 stores in the mall. 20 stores in the mall. What is the sample? Yeah, a random sample of 8 stores. The sample is the randomly chosen 8 stores. Now, why are we choosing them? We're trying to figure out what? What are we measuring? Yeah, the hours they would like to stay open during the holiday season. All right, so now we come across kind of the new part here is describe how you would determine your sample using the table from below. before. So first thing we need to do is label all 20 stores with a 2-digit number. Now you could start with 0-1, or you could start with 0-0. Depending on where you start or how you start, dictates what you do from there. As we talk about some things that in our describing our stuff. Let's just say we start with 2-digit numbers from 0, 1 through 20. Now we have to, using a table of digits, everybody's got to be the same number of digits long. So we can't go 1 to 20. We got to go 0, 1, 0, 2, 0, 3 as we use this table. So we're going to assign everybody a number from 0, 1 to 20. And then we're going to find the first 8 2-digit numbers on the list after randomly choosing a line to start. We will ignore repeats and the numbers 21 through 99 and also 00. So as we describe on our process here, we got to include kind of all that stuff. Is that, hey, we're gonna label all the stores with a 2-digit number, specify what it is. Then we're gonna find the first, and sometimes I've seen kids use the word unique, the first unique, first 8 unique 2-digit numbers. So the unique would go there, unique. That kind of implies that, hey, none of them are similar. On the list, we do need to, say how we're going to start. Typically, it's like just randomly closing your eyes and putting your finger down, and that's the line you start on. This one we're going to do a little bit different just because of I don't have the full table here. This table on the packet for the test is like 30 lines long. So you would truly have the opportunity to kind of wave the hand up in the air, point down, and then that's where you start. We will ignore repeats and the numbers between 21 and 99 and 00. You have to talk about what's going to happen with repeated numbers and numbers outside of your 2-digit acceptable range when you're describing on the AP test on a free response. So we're going to start on our table here. We're just going to start on line 101 just to make things a little bit easier. And what may help is if you go through and say, okay, you know what? I'm going to split this up into 2-digit numbers. And so I take like a vertical line and I start separating every 2 digits. And then that way I kind of have an idea. So now you don't have to, but notice how some of my 2 digits kind of go over from one line to the next line. There we go. And then that's all I'm going to do for right now, because I don't want to keep going down. I could, but I don't want to junk it up. So now we're going to go through, starting on the very first line, and we're going to say, all right, if you're a number between 0, 1, and 20, you get to be part of my survey. And I'm trying to get the first 8 unique numbers, 8 different ones. So 19, that gets to be on our list. That's in our little range there. 22 is not. 39 is not. 50 is not. 34 is not. 5 is. So 5 gets to be part of our survey. 75 is not. 62 is not. 87 not. 13 is. 96 is not. 40 is not. 91 is not. 25 is not. 31 is not. We now go to the next line and we just keep going until we get our sample of 8. Okay? We would keep going until we get our 8 samples. On the next line, 73 no, 67 no, 64 no, 71 no, 50 no, 99 no, 40 no. Oh, there's a 00, but we said 00 we did not use, so we don't use that one. 19, already used it, so we're not going to use it twice, no double dipping. 27, no. Another 27, another 75, no. 42, 26, 48, nope, so nothing really on that line. So now we skip down to line number 3. 45, no. 46, no. 77, no. 17, that's a newbie. And 9 right after it, 9. 77, no. 55, 80, 00 again. 95, 32, 86, 32, no. 94, 85, line 4. 52, no. 71, no. 13, whoop, we already used you. 88, 89, 93, 07, haven't used that one. So 07, we're up to how many? 6? All right, so 46, no. I see 2, 02. I just need one more. 27, no. 40, no. Did I miss one in there? I was going quick. Did I skip somebody? Did what? I can't hear you because the air conditioner. Which one? Did I skip anybody in the process? I was going fast. I don't think I skipped anybody in the process. Okay. So we're doing all right. So 7, 46, 02, 27, 01, 18. Am I at that stage now? 40, and then, or 01. 01 would be in there, right? And that would be my 8th. So then what we would go through and do is we would, 1, 2, 3, 4, 5, 6, 7, 8, perfect. We would list those companies out. And again, I didn't label the companies. Where are the companies? Oh, they're the companies. So we go up here and again label 01, 02, 03, 04, 05. We should have done that beforehand. 06, 07, 08, 09, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then we would list, okay, what are those 8 stores? Now we're going to save some time. And, I figure you can grab names and put next to those. And those would be the 8 stores we would send a survey to help us make our decision. Okay? Now, you could have labeled across. You could have said 01, 02, 03, 04, then came down. Now, will we, again, based on how you numbered, could we have 2 different groups being chosen? Sure. Because, the only one, there's very few of them that had, when I go horizontally labeling and vertically, will match up to the same number. So it is possible to have a different random sample. Okay? But again, the process was random. And that's the key thing. So that's using a table of numbers. And again, that table is there. I've seen it as snapshots on free response practice questions from the AP site where they'll do a snapshot and say, here's a little situation. What are the first 4 people, the first 4 in your sample? And so you would kind of go through the same process of marking off on there the piece of paper as you do it on the little sheet that they give you. So, and saying which ones are chosen. Now, we have some special types of random sampling. Suppose, as we look at a random sample, we're going to just talk about just a simple random sample, just generic. Suppose we wanted to estimate the yield of corn in your field. The field is in squares and divided into 16 equally sized plots, 4 rows and 4 columns. A river runs along the eastern edge of the field. We wanted to take a sample of 4 plots. So in this case, what we're going to do is we're going to go through and we're going to use the calculator to do this. So I'm going to split my screen here, grab my TI calculator. So if you don't have one, please go grab one. That way we can show you how to do this. And you may want to reset it just because I never know what my other classes are doing to it if you're using mine. And as I get my screen down some, as we go to use technology, we typically don't have to label, especially in this case, we don't have to label. If you were dealing the last situation like the stores to send surveys to, you would have to number all of your stores again. It doesn't matter in that case if you use double digits, since we're using technology to randomize or get the numbers. It's just when we're doing that table, we got to specify the 01 to 99 or whatever it is. To me, if you want to just get in the habit of always doing double digits for it, the key thing is if you had 121 people in your population, then we have to do a 3-digit number, 001, 002, and so forth. All right, so first thing we have to do here, when you reset a calculator or in general, if we go to do this process of say, randomly give me a number, we may get the same number, a lot of us, so it doesn't appear to be random. So what we do is what's called set the seed. We're telling the computer to start at a certain part, then use their algorithm to figure out what's going on. So one way to do it is use your phone number. We all don't have the same phone number. So if you go through and type in your calculator, your phone number, and then you press above the on button, it says the STO button with an arrow, which is store. So we got a little arrow there. Now we go into math, the math button, which is underneath the green button. Arrow over to PROB. Alex, it'd probably just be PRB on your calculator was what it'd be, if I'm not mistaken, because you got a black one, right? Calculator, TI-83. All right. So just a little bit different settings on those, but nothing major. Once I get there, the very first option, number 1, is random. So we're going to press enter. And then I'm telling it to take my phone number, put it into that random thing. I'm going to hit enter again. Boom. Now it's set up to where as long as you're not using my phone number as the example, when we start doing the process, we may get the same number, but it's not going to happen like a bunch of us. Okay, it's gonna randomize and give us a number in there. So we want to, as we do a simple random sample, we need to make sure again where our river is. Here's our river. We want to make sure that we pick 4 numbers or to have the calculator pick 4 numbers for us. So now what we do is we go through and go back into math, go back over to probability. And if we go down to option number 8 is random integer, no repeats. So it's going to tell me a random integer, no repeat. We use that option if we are doing a whole bunch at one time. So maybe you're grabbing 7 or 8 for your sample. That's when we use that one. Using option number 5 is fine, which is just random integer. That one is fine as well. So I'm going to scoot back up to 5 and use that. Basically, we say, what's our lowest number? 1. What's our biggest integer? 16. And then I'm just going to tell it to choose 1. All right, is all I'm going to do here. Again, you can tell it choose 5 or 6. The challenge is, in this feature, it could give us repeated numbers. It may give you 5, 8, 9, 5, and 12. So you might see the 5 listed twice, whereas that other one, the no repeat, will not repeat a number and knows to exclude repeats in that process, okay? So if you're wanting to get 4 all at one time, you could put a 4 in there. I'm just going to do one at a time here. So I'm going to hit enter on paste and hit enter again. And then that says 7. So 7 is chosen to that zone is being chosen. We're going to repeat the process again. So if you want to, you can type in and do all that stuff again, or hit second enter, and it takes the last thing that we did as a calculation and puts it on the screen. Hit enter again. It gives me another one. 11. That's another field. That's another zone chosen. I'm going to do second enter again and hit enter. And then 5. We haven't chosen that one yet. All right. And then last one, second enter. Enter again, and 3. All right. So there are my samples. Okay. Now, as we go forward, how many of you circled my numbers out of curiosity? Okay. How many of you used your own numbers that you got from your calculator? Which is good. Okay. So what's going to happen is as we do some stuff on the next part later on, you need to make sure that you use what you do for your things there. Okay. So our things will look a little different when we do some calculations. But here now we've randomly chosen. As I look at it, that's not bad. However, didn't one area get totally left off? Okay. Actually, we can look at several things. We can see that, hey, for one, this whole track here, nothing was chosen from that one. Now here's the other issue with this one by using just this one process. If I go in here, take a look at the row closest to the water, and then also, the third row. Nobody in those 2 rows were chosen. So now as I'm trying to decide based on the weight of my corn that were in those zones, I have 2 big zones not represented in there. I do have some vertically away or sideways away from it, horizontally away from the river. I do have the second row and the fourth row represented, but I don't have the first and third row represented. The closest place and then a little bit back as opposed to the far back. So when you're just doing a blanket simple random sample, sometimes parts are excluded. Okay? So that leads us into the next stuff. What we can go through and do as we look at some more random sampling. So as we look at 2 specific random sampling, what's coming up is a stratified random sample and a cluster random sample. These special types of random sampling, which are used in cases where we're concerned about a specific subpopulation that may be underrepresented in the sample. So I'm going to give you a chance to fill in those blanks there, and then I'm going to walk you through how we do what we do for this process. What does it mean for a stratified? In a stratified random sample, the population is classified into groups of similar individuals. This is named homogeneous groups. Okay, as a vocab word there, I wanted to point that one out there. That we see homogeneous groups, the groups of similar individuals. They are called strata. Once we put them into groups that are similar, then we do a simple random sample is chosen from each strata. And then we combine the simple random sample from each of those strata for our full sample. So in this case, our strata are the vertical columns. So I'm going to draw some vertical columns. So these are our strata. This is our stratified. So these are our strata. Bless you. Those are our strata. Now, what's similar about them? All those in those columns, they're the same distance away from the water. Okay, that's what they have in common. And then now what I need to do is I need to go through and do that random integer feature again. And I need to get, my sample 4, because n is 4 in this process here. I need to make sure one box in each strata is represented. So if a number comes up from the same strata, we ignore it as a repeat. So as I go back here and go back to my calculator, there we go. I'm going to again tell it to give me a random integer. So second enter, give me a random integer, 15. So I chose 15. So that means that second row cannot be used again. So if we see 11 and 7 and 3 come up, we just ignore them. So then I'm going to hit second enter and 11. Okay, there is a repeat in that strata, so I don't use 11. Let's go again. 14. All right, different one. All right. And then second enter, third one, 6. In the same strata as the 14. Have to ignore that one. 2. Same strata. Got 3 of the same strata there. Let's do it again. 7, same strata as the 15. 3, same strata as the 7 and the 15. Oh, man, goodness gracious. What are the odds? Anybody already have all 4 strata represented? All right, so it's my phone number's messing it all up. All right, enter. 7, same one. Oh, goodness. 5. Hey, there we go. Back there. All right, different strata. Now I just need somebody from the 4 through that one there. So, can I get lucky? No. Yay, 4. There we go. Now I'm done. So this allows me here. I got 1 from every row represented as I go through it and be able to compare some information here in a moment. So, so the key thing here, we continue process until each strata is represented. We're ignoring repeated stratas. Whoops. All right. So that was a stratified random sample. The next version is called a cluster sample. In a cluster sample, the population is divided into smaller groups called clusters. These groups should be represented by the representative of the entire population. So in this case, it is actually each of the rows. Each of the rows in our situation here. We have somebody, if as we go through. So when we get a number, as we do our simple random sample, as we get a number, whatever number comes up, that entire row is our cluster. We're done. So it's not a matter of making sure every row is represented. Every vertically the stuff is represented. It's just as soon as I get a number, that entire row is what my cluster is, and I'm done. I have all 4 rows represented because I'm using all 4 of the values in that cluster for what we're doing. So I put up at the top here, this is what we classify as being heterogeneous groups, is what this is classified as, in case you see that vocabulary come up. So as I split my screen, go to my calculator, split my screen, come on, split my screen. There we go. One more time, just one more. Boom, number 13. So that tells me that, hey, that entire row is part of my process. So as I look at my sample for this one, it's going to be 13, 14, 15, and 16. All right. Now, you may have gotten something else. If you're not copying down what I'm doing, you may have gotten something else. That's fine. Where the importance here is, and I'm going to go back and label each of my groupings off as like I did on that one there. What we're going to do now is they want us to compare. Here is the data that came across from each of the different zones on the yield, the mean yield amount of corn. And so we want to figure out, well, what is the mean of each of the samples that we got? Okay. So when I did the SRS, the very first one, I had 3, 5, 7, and 11. So I had 3, 5, 7, and 11. Those were my 4 things. So 3, 5. Oh, Mr. Stevens, you're bad. Oh, I can look up there. 3, 5, 7, 11. 7 and 11. There we go. So I want to find what is the mean of that. So what is the mean of 7 plus 94 plus 98 plus 92 divided by 4? Okay. I don't have a clicker calculator here. We'll go on the screen. Boom, boom, boom. We're going to leave that up here now. So 7 plus 94 plus 98 plus 92. Divide that answer by 4. And I got 72.75. Again, you got something different if you did your own random sample. All right. Now for the stratified. Option number 2. What were the zones that you used? I personally, on option number 2, I had 4, 5, 14, and 15. So I had 4, 5, 14, and 15. So 4, 5, 14, and 15. So I had those 4 zones. So 7 plus 150 plus 32 plus 97, all divided by 4. All right, 7 plus 150 plus 32 plus 97. Looks good. Divide that by 4. All right, 71.5. All right, now the cluster one. What did you do for the cluster? Mine was the bottom row. Mine was the whole bottom row. So 5 plus 32 plus 97 plus 147. Divide that by 4. 70.25. Okay. So all 3 of my sampling methods, for me personally, all 3 of them gave me a mean amount above 70. Did anybody have any of their random samples have something less than 70, out of curiosity? 1 or 2? Because it's possible. Because again, as you think about it, we notice the far left row has really small numbers. Same thing with the third row away from the river. So it is possible to get an average that is a lot different than 70. If the actual yield mean yield is 70, which method? Compare the methods that you use to get the actual. So for which one of the methods for you ends up look like it's the better one? Which one is closer to the true mean, the mean of 70? For me, my cluster sample was the best. All right, so my cluster sample was the closest. A generic simple random sample for me was an overestimate, a really big overestimate. Same thing with the stratified for me. But again, it's random. That's where sometimes the farmer or somebody may try to do this multiple times. And see if there's see if it's better or not. Now, last little part as we get ready to finish up here. Why is our sampling method? Why is it important? Because we're looking at inference. The purpose of sample is to give us information about a larger population. This is called inference, the process of inferring information from a sample to a large population. Again, that's the process we're looking at doing from Chapter 8 on, is what the focus is, that inferencing. Taking data from a sample, doing stuff, and inferring it to the greater population. It is unlikely that the results from the random sampling are exactly like the results from the total population. So why do we trust random sampling? Since the error is due to chance, not bias, the laws of probability can be applied. The laws of probability allow trustworthy inference about the population. Laws of probability also allow results from a random sample to have a margin of error, which is set bounds on the likely size of the error. One thing to remember, larger random samples give better information about the population than smaller random samples. And again, we get to talk about that more in the later chapters. Okay? Now, errors. What could go wrong with our samples? Sampling errors, mistakes made in the process of taking a sample that could lead to inaccurate information about the population. Bad sampling methods, choosing to do a voluntary response or convenience sampling. Under coverage are some sampling errors, when some groups of the population are left out of the process of choosing a sample. Here's an example. When sampling households in the United States using a simple random sample of phone numbers, what about the households that don't have phones? Unlisted numbers. How about people who are homeless or in prison, living in dorms? They're not going to be part. That is why it is really important to identify our population of interest and be specific about it. Non-sampling errors is errors that occur after a sample has been chosen. Examples of non-sampling errors are a non-response. This is when an individual in a sample does not participate in the study. A response bias is when an individual gives an untrue answer because they feel their response may reflect badly upon them. I've done that with just polling my class, like doing a quick little Google form and just say, hey, listen, your name's not attached. I did it last fall with for my honor stats class, where I still have a feeling that I almost want to say close to 70% of high school students use AI to cheat on their homework or have a friend tell them what their answers are. They do some form of cheating. That's what my feeling is. Okay. And so I gathered some data, and as I surveyed, I sent out a quick little thing to all the math AFT teachers, and I did a Google form. I said, share it with your kids, let them know that their name is not tagged to it. I had it disabled to where they gathered their Sumner K-12 email address, and I just asked a couple questions. Do you use AI to cheat on homework? Do you use a friend to tell you what the answers is, so forth? And what grade are you in? And when I got that information back, I mean, it was high. It may not have been 70%, but it was definitely not like 20% of kids. It was a majority of the kids that were surveyed, and I had close to about 400 results, said they cheat on their homework in some form or fashion. Okay, so that's where, when we look at, if I ask the question in class and everybody's sitting there, then somebody may tell me something, no, I don't cheat on my homework, when they actually do. And that's where we're talking about, sometimes we have that response bias where people will tell us something just to hear it that way. The wording of the question, confusing or leading questions may also lead to inaccurate response. Don't trust the results of a sample survey unless you have read the exact questions asked. Do you believe that the cell phones in your classroom interfere with students' learning and should be banned in the schools? Do you believe that cell phones can provide emergency access to students and should be allowed in schools? These are both questions that, under the guise of should cell phones be allowed in school, you can steer people's answers one way or the other. And then I'm going to let you write those things down. I realized afterwards, one, I got a typo. But two, a couple typos. Here are some pros and cons to random samplings for just the simple random sample, stratified, and cluster sampling. We do have a couple more that we'll talk about. We'll talk about a block design, and we also have what's called a matched pairs. Those are in the next lessons that we do. And that's more as we get into our experiments in the next lesson. Using those as we do things. So I'm going to let you copy that stuff down, and we'll kind of go from there. And as soon as I can find that out.